Hello everyone, this is Pranay. So today we are going to discuss about the topic the pigeonhole principle. So it is a fundamental tool in many branches of mathematics, and this principle reveals unexpected relationships and connections. So coming to the what is a pigeonhole principle? The pigeonhole principle is a simple but powerful counting argument that states that in any set of certain size, if there are more pigeons than pigeonholes, then at least one of the pigeonholes must contain more than one pigeon. But why it is important? So this principle has far-reaching implications across the mathematics, including combinatorics, probability, geometry, and graph theory. So it generally provides a way to think about counting problems in more systematic and precise way and can often lead to elegant and surprising solutions. And what are its some of the applications? So it has many applications from the practical such as scheduling and data storage to the theoretical such as proving the existence of prime numbers and theorems about infinite graphs. So first, if we discuss about combinatorics, here combinatorics is a study of counting and arranging the objects. And if we take an example, we have the birthday problem. Suppose if we have a group of 366 people, and what is the probability that any two of them will have the same birthday? So in this type of questions, we'll be getting the answer such as at least two of the people will have same birthday in a group of 366 people because a leap year consists of 365 days and we have a group of 366 people. Then at least one of the pair, that is at least one of the pair or any two members have the same birthday. And coming to the application and coming to the real-time application of number theory, we have Dirichlet's theorem, which says that there are infinitely many primes in any arithmetic progression. And coming to the graph theory, we have a basic theory known as Ramsey theory, which deals with the finding patterns and structure in the graphs. This principle is a powerful tool for proving many results in this area. And coming to some questions, the first question is, suppose if we have a deck of 52 playing cards, what is the minimum number of cards you need to deal to ensure that you have at least 5 of the same suit? Here the suit represents like hearts, spades, clubs, diamonds. So these are the four type of patterns in the deck of cards. Now, what is the solution? So to find a solution, we generally have a formula that is n minus 1 by p plus 1 is equal to number of cards drawn. So n represents, the small n represents the minimum number of cards that should be picked. And p represents the number of pigeons. Here in this question, the number of pigeons are like the number of suits. How many suits are there? 4. So n minus 1 by 4 plus 1 will be equal to how many colors should we need to get? Here at least 5. So the number of cards to be drawn is 5. So the total formula will be n minus 1 by 4 plus 1 will be equal to 5. If you solve that, you will be getting the answer 17. So the total number of cards you need to deal to ensure that you have to get at least 5 of the same suit are 17. If you want to further explore this type of questions, you can check with the number of cards that you have to ensure that you have at least 6 or 7 of the same suit. You can try that. And coming to the number theorems, here is the problem. Prove that for any 10 consecutive integers, there is at least one that is non-relatively prime to any of the others. So here's a solution. So by using the pigeonhole theorem, here we did, if we take 9 distinct prime factors among the 10 integers, so there will be at least one factor must be repeated. So if this factor repeats in 2 or more integers, then those integers are not relatively prime. Therefore, there must be at least one non-prime integer among the 10. So here we got the proof. So if you want to further explore this, you can use this Pigeon principle in modular arithmetic and Diophantine equations and etc. And coming to the last, here is about the graph theory. Yeah, you have a question about the graph theory. So here's the problem. Suppose we have a complete graph on the 6 vertices. That is, every pair of vertices connected by an edge. What is the smallest number of edges that can be colored red or blue so that there is no monochromatic triangle? Here, a monochromatic triangle represents a triangle whose edges are all the same in color. So, the solution. So, what is the solution? So, by the Pigeon principle, we can say that if we take 9 edges as only one color, that is red or on the blue, so if we assume there are 9 red edges, then there will be at least one vertex with at least 3 edges extending from it, which forms a red monochromatic triangle. So therefore, the minimum number of edges needed to avoid a monochromatic triangle will be 10. If there are 9, then if you take 3, 3, it will become a monochromatic triangle because the 3 pairs will be equal to triangle. But if you take a 10th edge, if you take a 10th one, 10th vertex, then we can avoid the monochromatic triangle. So if you want to further do this type of questions, you can do them on geometric concepts such as symmetry and dimensions. And coming to the last one, here this is the conclusion of our video. So here the Pigeon principle is one of the simplest and more versatile tools in mathematics. Whether you are a seasoned researcher or curious student, we hope this brief introduction has inspired you to explore the further and uncover new connections and insights.